January 24, 1942. The bitter wind howls across Greenland's frozen wasteland, carrying crystalline snow that stings like needles against exposed skin. At Narsarsuaq, on the extreme southwestern edge of this desolate island, a strange metallic gleam cuts through the endless white. Rows upon rows of perforated steel plates stretch across what was once nothing but tundra and rock. The deep rumble of aircraft engines breaks the Arctic silence. A C-47 Skytrain circles overhead, its pilot squinting down at the geometric pattern below, a runway that shouldn't exist, built from materials that seem to defy every principle of traditional construction. The steel matting lies flat against the earth, yet somehow promises to bear the weight of tons of aircraft and cargo. As the transport plane touches down, its wheels make contact with America's first operational pierced steel planking runway. The metal plates flex slightly under the impact, their thousands of precisely punched holes creating a surface that drains moisture while maintaining structural integrity. Each section weighs 66 pounds, light enough for 2 men to carry at a run, yet strong enough to support the heaviest military aircraft. 3,000 miles away, German intelligence officers will soon receive reports that will fundamentally challenge their understanding of modern warfare. The Americans haven't just built another airfield. They've created something that moves, adapts, and deploys like a mechanical organism across any terrain on Earth. The war's balance has just shifted in ways the Germans cannot yet comprehend. In the winter of 1941, the German war machine appeared unstoppable. From the frozen steppes of Russia to the burning deserts of North Africa, Wehrmacht engineers had demonstrated their mastery over the landscape itself. They carved airfields from solid rock, built fortifications that seemed to grow from the earth, and created infrastructure with the methodical precision that had made German engineering legendary across the world. German military doctrine emphasized permanent installations. Their airfields were monuments of concrete and steel, designed to last decades. Every runway represented months of careful surveying, massive earth-moving operations, and the deployment of specialized construction equipment that weighed tons. The Luftwaffe's bases dotted Europe like industrial cathedrals, each one a testament to German engineering superiority and their confidence in controlling territory for generations. This approach reflected a fundamental German belief about warfare itself. Victory meant conquest, and conquest meant permanence. You built to stay, you fortified to endure, and you engineered solutions that would serve the Reich for 1,000 years. The very idea of temporary military infrastructure seemed primitive, wasteful, and strategically naive. Meanwhile, across the Atlantic, American military planners faced a completely different reality. The United States would need to fight a two-theater war across vast oceans, establishing air power on islands, atolls, and foreign shores where traditional construction methods would prove impossible. They couldn't spend months building concrete runways on coral reefs or in jungle clearings. They needed something revolutionary. The challenge seemed insurmountable. How do you create solid, reliable airfields on terrain that changes with the tide? How do you support heavy bombers on islands where the only building materials are sand and palm trees? How do you move thousands of tons of construction equipment across an ocean, then deploy it faster than the enemy can react? German intelligence officers monitoring American military preparations through 1941 saw nothing that concerned them. The Americans were clearly struggling with basic logistical concepts that German engineers had mastered years earlier. Their military construction efforts appeared chaotic and experimental, lacking the systematic approach that characterized German engineering excellence. What the Germans couldn't see was the quiet revolution taking place in laboratories and testing fields across America. While German engineers perfected their concrete fortresses, American inventors were reimagining the very concept of military construction. They weren't trying to build better permanent bases. They were creating infrastructure that could move. The breakthrough began in December 1939 at the U.S. Army Corps of Engineers Waterways Experiment Station. The project brief was deceptively simple: create portable landing surfaces that could be assembled quickly on any terrain. What emerged from months of testing and refinement was something that would have seemed like science fiction to traditional military engineers. Pierced steel planking represented a fundamental shift in construction philosophy. Instead of pouring concrete, engineers would lay interlocking metal sheets. Instead of permanent foundations, they created surfaces that could be assembled, disassembled, and reassembled anywhere on Earth. Each steel plank measured 10 feet long by 15 inches wide, with precisely calculated perforations that provided strength while minimizing weight. The engineering brilliance lay in the details. The holes weren't random. They followed mathematical patterns that allowed drainage while maintaining structural integrity. The interlocking system used hooks and slots that could be connected without tools or specialized equipment. Two soldiers could handle each 66-pound section, running if necessary, assembling a runway surface that could support aircraft weighing tens of thousands of pounds. By November 1941, American engineers were ready for their first major test. During the Carolina maneuvers near Camp Macall, construction crews laid a 3,000-foot runway in just 11 days. General Henry H. Arnold, Chief of the Army Air Corps, landed on the completed surface and declared it the year's greatest achievement in aviation warfare. More importantly, the entire runway was then disassembled and shipped by rail to Langley Field for reuse. This demonstration revealed something profound about American industrial thinking. While German engineers built monuments, Americans were creating systems. The steel matting wasn't just about constructing airfields, it was about projecting air power anywhere on the planet with unprecedented speed and flexibility. Mass production began immediately. American steel mills, already ramping up for wartime production, received orders for millions of tons of pierced steel planking. The manufacturing process adapted automobile assembly techniques, creating standardized components that could be produced in vast quantities with minimal specialized tooling. Each sheet was identical, interchangeable, and designed for rapid deployment under combat conditions. German intelligence services monitoring American industrial activity through early 1942 noted increased steel production and unusual manufacturing patterns. Their analysts correctly identified a military construction project but completely misjudged its significance. They assumed the Americans were simply building more conventional military facilities, perhaps experimenting with prefabricated components to speed construction of permanent bases. The Germans' fundamental misunderstanding reflected their own engineering culture. They couldn't conceive of truly temporary military infrastructure because their entire strategic doctrine emphasized territorial control and permanent occupation. The idea that Americans might be creating instant, disposable airfields seemed wasteful and strategically pointless. The human dimension of this technological revolution became clear when the U.S. Navy construction battalions, the Seabees, began deploying across the Pacific. These weren't traditional soldiers, but skilled tradesmen, mechanics, and engineers who had volunteered for military service. They brought decades of civilian construction experience to military problems, approaching each challenge with the practical creativity that characterized American industrial culture. Unlike German military engineers who followed detailed technical manuals and established procedures, Seabees improvised constantly. They adapted pierced steel planking for runways, taxiways, hardstands, and even temporary buildings. They developed techniques for laying matting over coral, sand, mud, and solid rock. Most remarkably, they created assembly line methods that could transform raw jungle or barren atoll into operational airfield in days rather than months. The tactical implications were staggering. Traditional military doctrine assumed that airfield construction required extensive preparation, specialized equipment, and secure supply lines. Armies planned campaigns around existing airfields or accepted the months-long delay required to build new ones. The American system shattered these assumptions completely. A typical Seabee deployment could establish basic airfield operations within 72 hours of landing. Within a week, they could support squadron-level operations. Within 2 weeks, they could handle major bomber formations. The speed of deployment meant that American airpower could appear anywhere almost instantly, limited only by the ability to transport the steel matting and the men to assemble it. German intelligence networks gradually began reporting these capabilities, but the information seemed impossible to believe. Their analysts struggled to reconcile reports of rapid American airfield construction with their understanding of military engineering requirements. Early intelligence summaries dismissed many accounts as exaggerated propaganda or misidentified temporary facilities. The technological breakthrough extended beyond simple construction speed. Pierced steel planking created airfields that were genuinely portable in ways that defied traditional engineering logic. When American forces advanced, they could literally pick up their runways and move them forward. When they abandoned positions, they could deny airfield facilities to enemy forces by simply disassembling the landing surfaces. This mobility transformed strategic planning. American commanders could establish forward air bases to support specific operations, then redeploy those same resources to completely different theaters. The steel matting became a strategic asset that could be concentrated wherever needed, creating temporary air superiority through rapid deployment rather than permanent fortification. German military planners accustomed to thinking in terms of fixed installations and territorial control struggled to develop counter-strategies against this new form of warfare. How do you destroy airfields that can be rebuilt in hours? How do you plan defensive operations when enemy air bases can appear anywhere without warning? The psychological impact on German forces became evident as reports accumulated from across multiple theaters. In North Africa, German pilots began encountering American aircraft operating from bases that intelligence maps showed as empty desert weeks earlier. In Italy, Luftwaffe reconnaissance flights photographed airfield construction that seemed to progress at impossible speeds. The industrial scale of American pierced steel planking production amplified German concerns. By 1943, American factories were producing approximately 2 million tons of steel matting annually, enough to create hundreds of major airfields or thousands of smaller installations. The sheer quantity of material suggested American capabilities that German planners had never anticipated. German engineers attempted to analyze captured samples of American steel matting but found themselves confronting unfamiliar manufacturing techniques and metallurgical approaches. The American material used steel alloys with high manganese content, creating exceptional corrosion resistance and durability. The manufacturing process produced consistent quality across millions of individual components, aiding production capabilities that German industry couldn't match. More troubling for German analysts was the systematic nature of American deployment. This wasn't experimental technology being tested in limited scenarios. It was standardized equipment being used across every theater of operations. From Alaska to Australia, from North Africa to Italy, American forces were establishing airfields with identical techniques and materials. The strategic implications became clear as German intelligence pieced together the scope of American operations. The United States was creating a global network of instantly deployable air bases, each one capable of supporting major military operations. The Americans weren't just building airfields, they were projecting power across the entire planet with unprecedented flexibility and speed. German military commanders found themselves fighting an enemy whose logistical capabilities seemed to violate basic principles of warfare. Traditional military wisdom held that extended supply lines created vulnerability, but American forces appeared to operate independently of fixed infrastructure. They created their own airfields wherever needed, establishing air superiority through rapid deployment rather than territorial control. The moral dimension troubled German leadership even more than the technical challenges. American construction crews worked with enthusiasm and creativity that contrasted sharply with the forced labor that supported much German military construction. Seabees approached their missions with problem-solving energy that produced innovative solutions under combat conditions. German propaganda attempted to minimize American achievements by emphasizing the temporary nature of steel matting installations. They portrayed pierced steel planking as evidence of American inability to build permanent facilities, suggesting that temporary runways indicated strategic weakness rather than technological innovation. This propaganda effort backfired as German military personnel encountered American capabilities directly. Frontline reports consistently described American airfield construction as rapid, effective, and strategically decisive. German pilots and ground forces witnessed American air operations launching from bases that appeared overnight, undermining official propaganda about American technological limitations. The full scope of American capabilities became undeniably clear during the Marshall Islands campaign of early 1944. German intelligence services monitoring American operations through Japanese sources and their own Pacific networks documented airfield construction that redefined their understanding of modern warfare. On Majuro Atoll, Seabee construction battalions established operational airfields on coral reefs that had been underwater at high tide just days earlier. Using pierced steel planking over crushed coral and sand fill, they created runways capable of handling heavy bombers in less than a week. The speed of construction meant that American airpower was attacking Japanese positions before German intelligence services could even confirm the existence of new American bases. More shocking was the scale of simultaneous operations. American forces weren't just building individual airfields, they were establishing entire networks of air bases across hundreds of miles of ocean. Each installation used identical materials and techniques, creating standardized capabilities that could be replicated anywhere. The Americans had transformed airfield construction from a specialized engineering challenge into an industrial process. German technical intelligence officers analyzing reconnaissance photographs and captured materials began to understand the revolutionary nature of American steel matting technology. The pierced steel planking wasn't simply a construction material. It was a complete system that included transportation, assembly, maintenance, and redeployment capabilities. The Americans had solved problems that German engineers considered fundamentally impossible. How do you build solid runways on unstable coral? How do you establish air bases on islands with no natural construction materials? How do you create airfields that can be operational within hours of initial landing? The American system provided practical answers to all these challenges. What terrified German analysts was the realization that American capabilities were still expanding. Intelligence reports indicated continuous improvements in steel matting design, assembly techniques, and deployment procedures. The Americans weren't just using revolutionary technology, they were perfecting it through constant battlefield experience. The strategic consequences became visible in German defensive planning. Traditional fortification doctrine emphasized creating obstacles that would delay enemy advance and force extended sieges. But American air bases could appear behind German lines faster than conventional defenses could be constructed. The Americans were achieving strategic mobility that made fixed defensive positions obsolete. German commanders found themselves fighting an enemy that could establish air superiority anywhere without warning. American bombers appeared over German positions launching from airfields that intelligence services insisted didn't exist. Reconnaissance flights confirmed that Americans were operating on locations that had been empty wilderness just days earlier. The psychological impact on German forces was devastating. Soldiers who had witnessed the methodical precision of German engineering excellence now faced an enemy whose construction capabilities seemed almost supernatural. American airfields appeared overnight like military magic, defying everything German troops had been taught about military logistics and construction requirements. By mid-1944, German intelligence services compiled reports that revealed the true magnitude of American pierced steel planking deployment. American forces had laid enough steel matting to create over 300 major airfields across 6 continents, with construction continuing at an accelerating pace. The industrial output supporting these operations exceeded Germany's entire steel production capacity. The numbers were staggering and strategically decisive. American factories produced steel matting components faster than German forces could destroy completed installations. Even successful attacks on American airfields became meaningless when new runways could be operational within hours of reconstruction beginning. The Americans had achieved strategic invulnerability through speed of deployment rather than strength of fortification. German military planning documents from this period reveal growing desperation as commanders struggled to develop effective responses to American mobile airfield capabilities. Traditional sabotage techniques proved useless against installations that could be completely rebuilt in a single day. Artillery bombardment became strategically pointless when target airfields could be relocated faster than attack plans could be developed. The technological gap was widening rather than closing. German attempts to develop comparable capabilities foundered on fundamental resource and industrial limitations. Even if German engineers could design similar systems, their manufacturing capacity couldn't support the massive scale of production that made American operations possible. More troubling was the systematic nature of American deployment. This wasn't improvised battlefield engineering, it was carefully planned industrial warfare that treated airfield construction as a standardized manufacturing process. Americans were applying assembly line efficiency to military construction, achieving results that traditional military engineering couldn't match. The strategic initiative had shifted permanently. German forces found themselves constantly reacting to American air operations that could appear anywhere without warning. The Americans weren't just winning individual battles, they were controlling the tempo and location of the entire war through superior logistical capabilities. German intelligence assessments concluded that American pierced steel planking represented a fundamental transformation in warfare itself. The ability to establish air bases instantly anywhere on Earth meant that geographic barriers no longer provided meaningful defensive advantages. The Americans could project power across any distance with unprecedented speed and flexibility. The implications extended beyond immediate military operations. American steel matting technology suggested industrial capabilities that could support global military operations indefinitely. Unlike German forces, which were increasingly constrained by resource limitations and extended supply lines, American operations appeared to be expanding in scope and ambition. German leadership recognized that they were facing an enemy whose approach to warfare differed fundamentally from European military traditions. The Americans weren't trying to conquer territory in the conventional sense. They were creating temporary superiority wherever needed, then moving on to new objectives. This strategy made German defensive planning almost impossible. The German military response to American steel matting capabilities revealed the limitations of traditional European military thinking. German engineers attempted to develop countermeasures based on conventional approaches: better camouflage, more effective bombardment techniques, improved defensive positions. But these solutions addressed symptoms rather than the fundamental strategic challenge. German technical intelligence services launched intensive efforts to acquire American steel matting samples and manufacturing specifications. Through various sources, they obtained detailed information about pierced steel planking design and production methods. However, the intelligence proved strategically useless because Germany lacked the industrial capacity to implement comparable capabilities. The manufacturing requirements for effective steel matting systems exceeded German production capabilities by enormous margins. American operations consumed steel alloys, transportation resources, and specialized equipment that German industry couldn't provide, even if all other military production ceased. The Americans had achieved technological superiority through industrial scale rather than engineering innovation alone. German attempts to disrupt American steel matting operations focused on attacking transportation and supply networks. Submarine campaigns targeted American shipping carrying construction materials to forward theaters. Luftwaffe operations prioritized attacks on American supply depots and staging areas. These efforts achieved tactical successes but failed to slow American airfield construction significantly. The strategic futility of German responses became clear as American operations expanded throughout 1944 and 1945. Every destroyed American airfield was rebuilt within days. Every successful attack on American supply convoys was offset by increased production and alternative transportation methods. The Americans had created military capabilities that were effectively immune to conventional countermeasures. German military commanders gradually recognized that they were fighting an enemy whose approach to warfare represented a fundamental evolution in military capabilities. The Americans hadn't just developed better equipment, they had created entirely new concepts of strategic mobility and logistical support. The psychological impact on German forces intensified as the war progressed. German soldiers witnessed American construction capabilities that seemed to violate basic principles of military engineering. American airfields appeared in impossible locations, supported operations that traditional logistics couldn't sustain, and vanished when no longer needed only to reappear elsewhere. The post-war assessment of American steel matting operations revealed capabilities that had exceeded even optimistic German intelligence estimates. American forces had deployed approximately 2 million tons of pierced steel planking across global operations, creating temporary and semi-permanent airfields that supported decisive military operations in every theater of war. The strategic significance became clear as military historians analyzed the correlation between American airfield construction capabilities and successful military operations. In virtually every major American victory, rapid establishment of air bases had provided the margin of tactical and strategic advantage that determined outcomes. German post-war military analysis acknowledged that American steel matting technology represented one of the most significant innovations in modern warfare. The ability to establish air superiority anywhere within days had fundamentally altered the strategic balance, making traditional defensive strategies obsolete and enabling global military operations on unprecedented scales. The industrial implications were equally profound. American steel matting production had demonstrated manufacturing capabilities that German industry never approached even at peak wartime production. The systematic application of mass production techniques to military construction materials suggested American industrial potential that exceeded pre-war German estimates by enormous margins. German engineers studying captured American materials found themselves confronting manufacturing quality and design sophistication that challenged their assumptions about American technical capabilities. The pierced steel planking represented not just innovative engineering, but systematic industrial excellence applied to military requirements. The economic dimensions were staggering. American investment in steel matting development, production, and deployment exceeded $200 million in 1940s currency, representing resources that German war economy couldn't have allocated to comparable projects. The Americans had achieved military superiority through economic capabilities rather than technical innovation alone. The global scope of American operations became fully apparent on laws. After the war ended, American steel matting had supported military operations on every continent, creating temporary air bases in locations that traditional military engineering considered impossible. The technology had enabled truly global warfare for the first time in human history. German military education institutions incorporated American steel matting operations into their post-war curriculum as examples of revolutionary military innovation. German officers studied American construction techniques not just as historical curiosities, but as indicators of fundamental changes in warfare that would influence military planning for decades. The story of American pierced steel planking represents more than technological innovation. It reveals the power of systematic thinking applied to fundamental military challenges. While German engineers perfected traditional approaches to military construction, Americans reimagined the entire concept of battlefield infrastructure. The lesson extends beyond military history into broader questions about innovation and institutional thinking. The Germans possessed superior technical expertise, more experienced military engineers, and more advanced metallurgical knowledge, yet they failed to develop comparable capabilities because their institutional framework couldn't conceive of truly temporary military infrastructure. American success reflected cultural approaches to problem-solving that emphasized flexibility, standardization, and mass production over traditional engineering permanence. The steel matting program succeeded because American industrial culture valued adaptability and systematic efficiency rather than monumental achievement. The strategic implications continue to influence modern military planning. The ability to establish air power anywhere on Earth within days remains a cornerstone of American military doctrine, evolved from the pierced steel planking innovations of World War II. Contemporary military engineering still applies lessons learned from Seabee operations across the Pacific. The human dimension endures as well. The Seabees who assembled those first steel runways under combat conditions demonstrated that individual creativity and systematic organization could achieve results that seemed impossible according to traditional military engineering standards. Their legacy influences military construction doctrine worldwide. The German reaction to American steel matting capabilities ultimately reflected broader questions about military innovation and strategic thinking. The Americans succeeded not because they were better engineers, but because they approached warfare with different assumptions about permanence, mobility, and the relationship between industrial capability and military power. Today, as military forces worldwide grapple with challenges of rapid deployment and strategic mobility, the lessons of pierced steel planking remain relevant. The Americans demonstrated that revolutionary military capabilities emerged not from superior technology alone, but from systematic application of industrial thinking to fundamental strategic requirements. The runways that moved like conveyor belts changed warfare forever, proving that the most powerful military innovations come from reimagining the possible rather than perfecting the traditional.